Welcome to qnawire.
Okay, so this is the free body diagram for the block A. Okay, and the black arrow here is the direction of the impending motion for the block A. So therefore, the block A was experiencing 4 different forces here, which is the normal force from the block B and the gravity of the block A itself, and the tension from the string and the static friction along the surface. Okay, so if we consider the y-axis is perpendicular to the surface and the x-axis is along the surface, so therefore we can decompose the WA here. So we have WA cosine theta is the y component of WA, and WA sine theta is the x component of WA. So well, we know the block A at this point is in equilibrium. Okay, so therefore the net force along the x direction should be equal to 0. So we have T plus Fs minus WA sine theta is equal to 0. So therefore WA sine theta is equal to T plus Fs. And along the y direction, the net force is also equal to 0. So we have the normal force N minus WA cosine theta is equal to 0. So therefore WA cosine theta is equal to N. And we know the static friction is equal to mu S times N, which is equal to mu S WA cosine theta. So eventually we have WA sine theta is equal to T plus Fs, which is equal to T plus mu S WA cosine theta. So therefore tension T should be equal to WA sine theta minus mu S WA cosine theta. And then this is the free body diagram for the block B. Okay, so the block B should experience 4 forces as well. My bad, it's actually 5 forces. Okay, so it should experience the gravity of itself, okay, which is WB here, and it should experience a normal force from the block A, which is NA here, and you should also experience a normal force from the surface, which is N here, and there's a tension here as well from the string, and also static friction between the block A and block B. Okay, since there's no friction between the block B and the surface, since there's no coefficient of the friction between block B and inclined surface. And the black arrow here is the direction of the impending motion for the block B. Okay, so since we know there's an angle theta here, so we can decompose WB, which is WB cosine theta and WB sine theta here. Okay. So well, we know since block B is also in equilibrium, therefore the net force along the x direction should be equal to 0 as well. So we have T minus Fs plus WB sine theta is equal to 0. So eventually have tension T is equal to Fs plus WB sine theta. And the net force along the y direction should be equal to 0 as well. So we have N minus NA plus WB cosine theta is equal to 0. So eventually have N is equal to NA plus WB cosine theta. So therefore we know the static friction is equal to mu S NA. Okay, since there's no coefficient of the friction between the block B and surface. Okay, so therefore Fs can be equal to mu S WA cosine theta. If we plug in back to the equation, we have tension T is equal to mu S WA cosine theta plus WB sine theta. And remember, the tension in block A is equal to WA sine theta minus mu S WA cosine theta. And we know these two tensions are equal to each other. So therefore we have WA sine theta minus mu S WA cosine theta is equal to mu S WA cosine theta plus WB sine theta. So therefore, if we divide by cosine theta on each side, we eventually have WA tangent theta minus mu S WA is equal to mu S WA plus WA tangent theta. So therefore, tangent theta is equal to 2 mu S WA over WA minus WB. So we know mu S is equal to 0.15, WA is 50 pound, WB is 25 pound. So therefore, tangent theta is equal to 2 times 0.15. times 50 pound over 50 pound minus 25 pound. And this will give us the tangent theta is equal to 0.6. So therefore, angle theta is equal to inverse tangent function, which is tangent to the power -1, and what's inside 0.6. And this will give us the angle is about 31.0 degree. And this is the answer for this question.